Problem number 49. Let D be the region bounded below by the plane z is equal to 0. Above by the sphere, x squared plus y squared plus z squared is equal to 64. On the sides by the cylinder, x squared plus y squared is equal to 16. Set up a triple integral in cylindrical coordinates to give the volume of D. We don't have to worry about evaluating it. Okay, so what is going on here? Okay, here are our axes. We have a sphere of radius 8. Let me draw a sphere of radius 8 here. And the idea then is that there is a cylinder of radius 4 in the xy plane, parallel to the xy plane. It just keeps on going infinitely up and down, but that's where it's going to intersect here. And let's see, it's going to be bounded below by the plane z is equal to 0. Okay, we want cylindrical coordinates, which means we're looking for bounds on z, on r, and theta. Okay, there's no specific x and y dependence here, so theta is just running from 0 to pi. We're going one loop around the polar circle here. R, the biggest R can be is, we take a look at the x squared plus y squared is equal to 16 equation. That's r squared is equal to 16. That's r is equal to 4. So the biggest r can be here is 4. Smallest r can be on the z-axis would be 0. And then z, the smallest z can be is 0. And then the largest is when we hit the top of the sphere. So we have to take our sphere equation and convert this to cylindrical coordinates. X squared plus y squared will become r squared plus z squared is equal to 64. Rearrange, z squared is equal to 64 minus r squared. Z is equal to the square root of 64 minus r squared. We are going above the plane z is equal to 0, so we want the positive root here. So these are our bounds here. We're asked to find the volume. Okay, so for the volume, how do we do this? We're going to be integrating. The bounds here, 0 to pi, 0 to 4, 0 to square root of 64 minus r squared, 1 times r dz dr d theta.